Last few chapters have covered all the core concept of JSON processing in Snowflake. We started with the purpose of JSON data files, the different type of JSON files in the data engineering domain, and worked our way through processing simple to complex deep nested JSON data. We covered loading from a local computer to Snowflake tables as well as from an S3 bucket, handling errors using the flatten function and file format parameters to handle special cases in the JSON data file. If you want to fully understand the concept of Snowflake JSON SQL function, including when to use them and when not to use them, it would be beneficial to watch all the previous chapter in this playlist. In this chapter, we will primarily focus on three JSON based SQL built-in function and explore how they work and in what order they should be used for a different use cases. So, we will talk following topics and also try hands-on exercise. Parse JSON function, try parse JSON, check JSON, and their limitation including their input output expectations and behavior. If you would like to practice the concept covered in this video, please stay tuned until the end and I will share the link that allows you to download the SQL script and the sample JSON files. Welcome back to my channel Data Engineering Simplified and to this Handling JSON Data in Snowflake playlist for true data professionals like you. This is a complete playlist covering JSON handling in Snowflake. Link to all the chapters can be found in the description section below or by clicking on the information icon above. So let's start with chapter 9, how to use JSON functions in Snowflake. Let's first talk about parse JSON SQL function. We have briefly discussed and used this function in our first chapter in this playlist. This SQL function takes a valid JSON text or a varchar and returns a JSON compliance variant data. If the input string is an invalid JSON text, this function ends with an error. The input value can also be an expression or a column from a table. This function cannot take more than 8 MB of data. So, if you have a column and that column holds a JSON string of 8 MB or a more, this SQL function cannot process it. We will also see how this JSON treats empty string or null inputs and order of keys inside the JSON string. So let's jump to our Snowsite web UI and start practicing it. This is our Snowsite web UI and this is my first worksheet called parse JSON. I am using this parse JSON function with a select statement with a very simple JSON construct. Let's first see how does it look like in our JSON visualizer. So this is a valid JSON and if you look into the visual diagram, here it is a key and here it is a value. Now let's run this parse JSON and it should return a JSON compatible variant. When I hover on this icon, it says it is a variant and I can see my complete JSON object. What if I try to pass an array to the parse JSON? How does it work? Let's run this statement. And this also able to translate this dataset without any issue. Let's try this another example. Here it also managed to process the JSON data type without any issue. Now what happens if I give an empty array or an empty object? This function can take empty array and returns an empty array. If I give empty object as an input, let's see. So it executed successfully. It returns an empty field. So when I have these two cases, it does not return null. Rather, it returns an empty array or an empty object because both of them are valid JSON. Now what happens if I try to give an empty string or a null object? Let's see. So empty string returns a null value, and if I try with null value, it also return a null value. However, this null is not an SQL null, it is a variant null. Now what happens if I try to give an invalid JSON? And before that, let me put this JSON in our JSON visualizer and understand whether it is valid or not. So this is an invalid JSON, okay. Now it could not parse this JSON because it is an invalid JSON and it says unknown keyword. So if your JSON text is an invalid JSON, the parse JSON ends with an exception and it cannot process invalid JSON text. Now let's try to understand the order of the key. Here I have a JSON text and let's check the JSON text in a JSON visualizer first. Here on my JSON visualizer, it is my key, your key and our key. There are three keys and this is how it looks like on a visual screen. What happens when I use this function? Whether this function is able to maintain the order of the keys or not. Let's run this function. When I click on this result, it says my key, our key and your key, which is different order of this text. So parse JSON does not guarantee the order of the key. Now let's try another example where I'm giving the number as a key value and the value start from 1 to 6. Here, the order is maintained. However, as per the documentation, it is not guaranteed that the order of the key will be maintained. So when are you processing your JSON data, make sure that the order of the keys will not be guaranteed if you are using parse JSON function. Now let's try to see how can you pass a column to the parse JSON function. For that, I am going to create a table called employee table and I am inserting couple of records. The first is a valid JSON record of key value pair, second is a null, third is an empty string, and fourth is an array. Let me insert this dataset. So total 4 record inserted. Now let's run the select statement. So I can see this is a text. This is also text. Looks good. Now I am going to pass this JSON text, which is a varchar, to this function JSON parse JSON, and let's run this statement and see the behavior. So this has resulted to the JSON compliant variant data. Looks good. Now what happens if I try to insert a varchar which represent an invalid JSON, and let's check whether it is invalid JSON or not. So it clearly says that it is an invalid JSON and it expects either a closing bracket or a comma. So since employee table does not have a variant data type, it will accept this string. So one record inserted and let's see how does it look like. So this record exists inside my table. When I try to run this select statement where I'm using the parse JSON with this JSON text as a column, let's see what happens. It says error parsing JSON incomplete object value at position 21. However, it doesn't tell which particular row ended with an error, and that is a challenge with the parse JSON function. So along with 8 MB as a upper limit, if you're trying to use this function during your ETL process, and if your ETL process fails with invalid JSON data type, then it would be very hard to validate which particular line item has ended with an error, because parse JSON doesn't support or doesn't indicate which particular row has ended while parsing the JSON data. We have seen some of the limitations of parse JSON SQL function. Now let's discuss about try parse JSON SQL function. This function also mimics the same signature as a parse JSON, and as name suggests, try followed by parse JSON, this SQL function tries to parse the JSON string, and instead of returning an error as we have seen, it returns null if the JSON is not a valid JSON text. It has similar limitations like it cannot process more than 8 MB of text and the order of key value is not guaranteed. So let's see them in action. Back in my web UI, and this is my another worksheet called try parse JSON. Let's use this function try parse JSON and provide a valid JSON text. It has written a valid value, looks good. Now this is my invalid JSON because my key and value are not enclosed in a double quote, and my JSON visualizer is complaining about its validity. Let's go and run try parse JSON function. So the parse JSON function ends with an exception. However, let's see how try parse JSON behaves. It has not ended with an error, rather it has written a null value. It tried converting this invalid JSON into a JSON compliant variant data. Since it could not do, it returned a null value. Let's try with simple array. It has worked. And let me make a mistake here. Let's rerun. It returned null. So this is how this try parse JSON function works. Let's try to see how does it behave for empty array and empty object. So the behavior is same, more like a parse JSON. Now what happens when I try to use the try parse JSON with a null value? Okay, so it has returned null. Now let's try to use the try parse JSON where the first instance is taking a null value and the second instance is taking an invalid JSON. Let's run this SQL statement. Both the expression gave null value. Now it is difficult to understand whether this null has come because the field itself having a null value or if it is having an invalid JSON. And this is what the limitation of the try parse JSON function. So according to your use case, if you can ignore an invalid JSON before it is being processed, maybe try parse JSON can help you and you can use the try parse JSON confidently if your use case support ignoring the invalid JSON. However, if your use case has to understand if it is a valid JSON or not a valid JSON, and if it is not a valid JSON, what is causing the invalidity, then probably in that case, try parse JSON is also not a helpful function for you. Now let's see what happens if I try to use a column from a table. For that, I am going to create a table called employee02. So the table is created successfully. So we have seen this example. I am going to insert 4 records. Let's check how does it look like. Let's see how the data looks like. So I have total 4 record. All of them are valid JSON. Now I'm going to use try parse JSON and give this column as an input. So employee ID 1 and employee ID 4 has returned valid JSON value. Employee 2 and employee 3 returned null value. However, this is not null, this is an empty. So this is how the try parse JSON behaves when you have to parse the column which has a JSON text. Now let's try how does it behave with invalid JSON, and for that I'm inserting my 5th employee. And I am making some quick changes here. Let's see the behavior of parse JSON first. As expected, it ended with an error and I did not get any result. Now let's try with the try parse JSON function. Now what happens? Here is my actual JSON text. Here is my text which has generated after using the try parse JSON. Employee 1 and employee 4 data has appeared properly. However, employee 3, where I have an empty string, ended with a null, and when I have invalid JSON for my 5th employee, it also ended with a null. So now you know how to use try parse JSON and when to use try parse JSON over a parse JSON. Now the problem here, when you are processing a large number of records which has a JSON as a text data, you need to understand what's going wrong, and these two functions do not allow you to identify what's going wrong. So we will see what function we can use to validate whether it is a valid JSON and or an invalid JSON, and if it is not an invalid JSON, what is causing that invalidity. Experienced how the parse JSON and try parse JSON SQL functions work. Let's talk about another function called check JSON SQL function. This function expects either a JSON string text or a JSON compatible variant data type. This function checks the validity of a JSON document. If the input string is a valid JSON document, the output is null, means it is a valid JSON object. If the input cannot be translated to a valid JSON value, the output string contains the error message. This is an interesting function which can help you in many ways during your development or while building data pipeline with JSON dataset. So let's see them in action. Snowflake Web UI, and this is my third worksheet called check JSON. First, we'll use this function by passing a valid JSON text, and let's see how does it work. As per the definition, this is a valid JSON input and that's why it should return null. So this is a null and this is a null string. Just because it is returning a null, it doesn't mean that it is not a valid JSON. Actually, null represent a valid JSON. Now I have another JSON text, and here if you see there is a double quote missing, and let's validate this into our JSON visualizer. So when I hover, it says it expects an end of string. Now, when I use check JSON function, it should complain about this invalid JSON. Let's try it out. It says in line number 5, position 0, it is unterminated string, and that's what we expect from this function. And the moment I fix it and rerun it, it clearly gives a null value. It means the JSON is a valid JSON. Now let's quickly try an array JSON and see how does it behave. Null is expected and it returned null. Let's try this one. Looks good. If I give an empty array, how does it work? It should return null. Yes. If I give empty object, it should also return null. And if I give an empty string, let's see what happens. As expected. And if I give a null value, it should also return null. Now let's try to pass a column from a table. For that, I am creating employee03 table. And I am inserting 5 different employees starting from employee 1 to employee 5. My employee 5 is an invalid JSON text. Let's check the data first. So I have total 5 record. Out of 5, employee 2 is null, employee 3 is empty string, and employee 5 is invalid JSON. Now let's use the check JSON along with a JSON text as a column, and let's see what is the output. And here, what I'm expecting for all other valid JSON document, this function is returning null. However, for the 5th employee, where it is not a valid JSON, it complained with a message saying that incomplete object value position 21. This is how the check JSON function can be used to understand why a particular JSON text is not able to convert into a valid JSON document. See how these SQL functions work to process the JSON text and what kind of output is returned based on different input parameters. Now let's try to use them for a large table which has JSON data as a string, and since this is a large data set, it is hard to find if it really holds valid JSON or not. So let's use these 3 functions together to generate a valid output and also see how the performance looks like when we use this function for a large data set. So I am in my new worksheet called all together. So I have a table called parts JSON as a text, and let's see how the data looks like. So I have part key and followed by the entire part text as a JSON object. Now let's see how many records do I have in this table. It has total 5 million records. Now if I just use the parse JSON function, let's see what happens. It says that one particular JSON failed and we do not know which particular row had failed, right? It is not exactly telling the row number and the JSON file text, and it is hard to debug using the parse JSON function. Now I can do one alternate thing. So if I modify the same query and try to use try parse JSON, it will help me to understand which all JSON failed to translate, and based on the part key, I would be able to debug that. Okay. So these are the parts key which are having some issues, and that's why they did not appear on the screen. Now I would try to use the check JSON function along with the parse JSON function, and in a single query, I would like to understand what is failing and why it is failing. So I am running the case statement using this SQL. So first I am printing my part key, then I have my first case statement which will use the check JSON function with this JSON text. If it is null, then it is a valid JSON. If it is not null, then it is not a valid JSON, and I am giving a name called JSON validity flag. I am using another case statement where if the check JSON returns null, it means it is a valid JSON, and use the parse JSON function to convert the JSON text into a valid JSON variant data type. If it is invalid JSON, then I'm creating another JSON with error message printed in this row. Okay, you can pause and understand how this query is written, but let me run it meanwhile. So it took quite a lot of time, close to 18 seconds. And let's see how the result looks like. So this first two rows has given not a valid JSON, and it is clearly saying missing colon and here invalid character, right? And rest of the JSON is a valid data. Let's quickly go and check how the query history looks like. So when I come to the query history screen, it says that table scan took a small amount of time compared to the overall time because I use the order by for valid or invalid JSON. That's why the sorting is used here, followed by the result. If I just avoid the sorting, maybe it will work slightly faster. However, if you have a complex JSON and there are a lot of invalid JSON, obviously it will take little extra time. So you have to make sure that when you loading your JSON data, you have to ensure the JSON data is validated before it is arriving to a Snowflake, else it will be an expensive operation running those queries on the top of those invalid or a valid JSON object. So we have learned almost all the key features with respect to JSON data file loading, JSON validation, and JSON processing. Now, it would be interesting to explore how to load JSON data continuously into Snowflake using pipe object and cover the interesting topics like how to configure continuous data loading with JSON file, how to run copy command, and what is the role of file format and external stages, how to track errors while loading continuous JSON data files, and also understand if there are any alternative approach to load the data continuously, along with best practices around them. I hope you have been enjoying this playlist and will surely watch the next chapter to learn more about JSON data file processing. Don't forget to explore my other playlist which covers wide variety of topics including Snowflake certification and mock test. And if you feel that my content is helping you, please do subscribe to this channel and do share with others. Thank you and happy learning and keep growing.